All right, here we go. Put away all electronics, please. Here we go. Y'all ready? Number 13. Number 13. Somebody get that door, please. Because I feel like a breeze and I'm already cool, you know. Damn. All right, here we go. It says, answer the question by writing an equation and determining whether the solutions of the equation are real or non-real. Answer the question. A gardener has 140 feet of fencing to put around a rectangular vegetable garden. The function A of W equals 70W minus W squared gives the gardener's area in square feet, or any width W in feet. Does the gardener have enough fence for the area of the garden to be 1,300? So, look up please. Now, when you get to these kind of problems, they're going to give you a problem that looks similar. It might not be the exact same in regards to a gardener. It might be like a projectile or whatever the case. But they're going to ask a question in regards to, do they have enough or will it reach this point? So in this case, check this out. I'm going to take the equation A of W equals 70W minus W squared. And they're asking, will he have enough fencing for an area of how much? 13. So that means here instead of the area, I'm going to substitute 1,300. 1,300 equals 70W minus W squared. So first things first, I want this written in standard form, and you need to get everything to one side. So what do? Subtract 1,300, subtract 1,300. We end up with 0, and now we write it in standard form. What do I write first? Negative W squared plus 70W minus 1,300. All right. So here we go. First of all, they want us to know if he's going to have enough for this whole thing. Well, question. What does that mean in regards to a quadratic equation? The question is, will there be a what? What was the question on top? Solutions to the equation that are what? Real or non-real. If they're non-real, that means that there isn't enough fence. But if they are real, guess what? There is fence. So without solving it, how can we figure out if there's going to be solutions? Talk it over to your neighbor, please. How can we figure out if there's going to be solutions for this one? Very good. B squared minus 4AC. We just did one of these, yes? All right. Let's see. Let's identify our values. What is A, everyone? -1. B, 70. And C, -1,300. All right. Let's substitute values. We got 70 squared minus 4 times A times C. A is -1, and C is -1,300. All right. What is 70 squared? 4,900. That is correct. Next, negative times the negative times the negative, negative, okay. 4 times 1 is 4 times 1,300. 5,200. Okay, so what do we get? Negative 300. Tell your neighbor what that means in regards to the problem. Non-real. Therefore, what would we write in a statement in regards to this problem? It says, a gardener has 1,400 feet of fencing for his garden. Does the gardener have enough? The gardener doesn't have enough for that area. 10 cubed. Did we need to solve or do anything else? No, because that's telling us that we're not going to get a real solution. That's what making us save time instead of solving the whole thing. Does that make sense? Ten cubed? 10? Period? Area. It's so clear. All right, copy this one. Example, what number was that? 13? 13 cubed. Here we go. Ready? Let's see. Joaquin throws a ball with a trajectory of y equals negative x squared plus 5x plus 6. Joaquin, 13 cubed. Trajectory. Trajectory. Okay. So, I'm not going to elaborate more, not to get you confused. So, question. Check to see if that one would have real solutions to the problem. How would you check? Tell your neighbor, please. Okay, let's see. B squared minus 4AC. What is A? Negative 1. What is B? 5. What is C? 6. So therefore, 5 squared minus 4 times negative 1 times, positive 6, sorry. Positive 6. So this is 25 plus what? 24. This is 49. What can we conclude? There will be a solution. Therefore, check this out. At this point, the problem might say, then how long will it take for Ryan to get to the trajectory of the ball and catch the ball? How many seconds? Then you just substitute the values in for x to solve. Or if it's a height over here, whatever the case. Does that make sense? But first, what are we going to check to see if it has solutions? All right, go to number 14. It says graph the circle after writing the equation in standard form. Now, by now, you should be able to do these, yes? Okay, I'm going to give you 2 minutes head start. Ready, go. All right, here goes the process. For those of you that forgot, here we go. To write this in standard form, we need to get rid of the constant, number one. And number two, we need to group like terms or variables of the same kind. So what do? I subtract 25 to each side. And at that point, I'm going to rewrite this. I keep the x's together. So this is x squared plus 6x. You leave an empty space here. Plus, you keep the y's together, y squared negative 10y, y squared negative 10y. Leave an empty space. And all that equal to negative 25. Now, we need to complete the square. I'm going to show you the steps so that you can see what we do in the noodle, what we've been doing all week, this week. We need to add b over 2 squared. What is b? 6. So we add 6 over 2 squared here. So what do I write here? You add negative 10 over 2 squared. And whatever we do to one side, we need to do to the other side. 6 over 2 squared plus negative 10 over 2 squared. Now, some of us are already experts, so we actually skip this step and we just write in there what it is. Is that correct? So here it goes. So I'm going to write in there what it is. X squared plus 6x. What is 6 divided by 2? 3. What is 3 squared? 9. Plus y squared minus 10y plus, that's negative 5 squared, that's 25. And all that equal to negative 25 plus 9 plus 25. Next, I'm going to simplify this. What is negative 25 and 25? They cancel. And now we're going to rewrite these by factoring. How do we factor? Use a shortcut. Square root of the first. X, square root of the last. 3, sign of the middle term. Positive, and we write that squared. Plus, square root of the first. Square root of the last. Y, 5, sign of the middle. Negative, and write that squared. And all that equal to 9. This is our standard form equation. Hands if you got that by yourself. Yeah, we got these by now. But they're asking us to graph. So what do we need to graph? We need a center. So I want you to write C, parentheses. Those of you that already did it, that's fine. Now we get H and K from here. This one's supposed to be a negative here, but it's a positive. So that means our H is going to be what? Negative 3. What is our K? 5, because it does have a negative. Okay. What else do we need to graph? We need a radius. How do we find the radius? We take this constant and take the square root. What is square root of 9? 3. Now that we have all that, let's graph. Let me zoom out. Here we go. Negative 3, 5. Negative 3, 5 is right there. My radius is 3. That means a point. There's going to be a point 3 steps away from the center in all directions. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then you sketch your circle. There you go. Show me your fingers off MPR with these. Yeah, we got these, yes? Okay. Number 15. Oh, yeah. Yeah, we've been doing these all week. So, all right, let's see. 15, it says, find the equation of the parabola with vertex 0, 0. And then they give us the focus, negative 1, 0, the directrix, x equals 1. So let me zoom in. Let's plot those first. I usually use red for my focus, negative 1, 0. I use blue for my directrix usually, so this goes there. So what does that mean, Mr. Q? That there's a straight line going through the directrix point, which is there. Yes? Oh, my bad, it's going by 2's. Yeah, I did that on purpose to see if you're paying attention. There you go. All right. So our vertex is at 0, 0. Plot your 0, 0 right there. There it is. All right. So let's see. To graph this, we need to see what kind of parabola we're going to have. It looks like it's going to go away from the directrix towards the focus, so it's going to go this way. Look up, like this. So if it's like this or like this, it's a horizontal parabola, which means our equation is y squared equals 4px. But we need to substitute for the variable p. What value do we substitute, everyone? Negative 1. Bring down the rest. Y squared equals 4 times negative 1 times x. Y squared equals negative 4x. All right, let's get some values. X, y, and now we're going to use, since we have a y form equation, we're going to do negative 2, negative 1, nice, 0, 1, 2. So I'm going to start with the first one. What's my first value that I'm going to substitute in there? Negative 2 of y, Mr. Q. All right, good. So I'm going to do this. Instead of y, I substitute negative 2. What is negative 2 squared? Positive 4 equals negative 4x. Let's solve for x. Divide by negative 4. Negative 1 equals x. That goes right there. What other y value is going to have the same x value? 2. So I write it right here. Do I need to do any more work? No, that's all I need to graph. Let me plot this. Negative 1 of x, negative 2 of y. Negative 1 of x, negative 2 of y, which is right there. Negative 1 of x, 2 of y. Bless you. There it is. See, good thing you're here in Saturday Academy and not distracted or on your phone, right? Pretty good, right? Yeah, because what's the point of coming to Saturday Academy if you're going to be doing other things? Woo! Yeah. Go to number 16. All right, I'm going to give you a head start for that one. Go. All right, let's see how you did. Here it goes. First, in red, I'm going to plot my focus, which is 0, 2. The directrix point is y negative 2, which is right there, which means there's a straight line going through y negative 2. And my vertex is still at 0, 0. Hands if you did up to right there. Okay, good. So what does that tell us? That the parabola is going to open up or down, but in this case up, so this is a vertical. That means we're going to write x squared equals 4py. What was the previous one? Y squared, because that's horizontal. So, and same thing, we're going to take the focus, the value in the focus, and that's going to substitute for the value of p. So this is 2. So we end up x squared equals 4 times 2 times y. X squared equals 8y. All right, let's get our table. X, y, -2, -1, 0, 1, 2. And I'm going to substitute my first value, -2. -2 squared equals 8y. This is 4 equals 8y. Divide by 8. Therefore, 1/2 equals y. So if for x -2, it's 1/2. What is it for x equals 2? 1/2, because it's a parabola. It's going to give us the same value. Do I need to do the other points? That's if you would like to. That's why I wrote them in there. But you don't have to. I just need 2 points. Therefore, -2, 1/2. -2 and 1/2 is about right there. 2 and 1/2 is about right there. So my parabola is right there. Hands if you got that. Piece of cake, right? Am I right? Am I right? What is, I think the most challenging part of this final is maybe the first 10, because it was stuff that we saw towards the beginning of the curriculum. Is that correct? Just refreshing it. But other than that, this should be fresh on your noodle. All right? Let's move on. Go to number 17. It says, solve each linear quadratic system algebraically, which means solve by substitution. All right, here we go. Ready? All right, here we go. My suggestion to you is to solve the linear equation for one of the variables, and usually it's for y. So make a note. Solve the linear for one variable. Solve the linear for one variable. Now, by now you should be able to recognize which one's the linear and which one's the quadratic. Tell your neighbor which one's the quadratic and which one's the linear. The quadratic is the one with the squared. The linear should be this one. So let's solve for y. So what do? Minus 2x minus 2x. And we end up with, I'm going to write it over here, y equals negative 2x minus 2. All right, so question. What is the y value here, they say? Negative 2x minus 2. So for the second equation, instead of writing y here, what do I write? Negative 2x minus 2. So let's do that right now. Negative 2x minus 2. Bring down plus 3 equals parentheses x minus 1 squared. Let's simplify. This becomes negative 2x plus 1 equals x minus 1 squared. Okay? Now, to solve this, we need to leave x by itself, but we have x's on both sides, which means we need to multiply this side. So tell your neighbor how we're going to multiply this side, please. All right, very good. X minus 1 times x minus 1. Here we go. Distribute x squared. Distribute negative 1x. Distribute negative 1x. Distribute positive 1. So this is x squared negative 2x plus 1. Bring this down. Negative 2x plus 1. All right, let's get all of them to one side. So what do I do with this, guys, to get it to the other side? Add 2x and subtract 1. Add 2x and subtract 1. 0 equals x squared, and what happens here? They cancel. So what do we do here to solve for x? So therefore, 0 equals x. Okay, am I done? No, we need a y value. Where do you want me to substitute that into? The quadratic or the linear? So that means I'm going to bring this one down. Y equals negative 2x minus 2. Y equals negative 2 parentheses for the x. And what is the value for x, everyone? 0, which is here. So we end up with y equals negative 2. All right? So, am I done? This is and I'm talking over this one because this is the common mistake that some of you do. Some of you do the beautiful work. You do everything right, and you leave it like that. So you never, what would be the mistake if I leave it like that? There's no solution yet. What's my solution? 0, negative 2. 0, negative 2. That's my solution. All right? Let me zoom out so you guys can see what it looks like. So that means the line and this quadratic are going to intersect there. That means it's only going to touch the quadratic or the parabola at one point. So let's see. 0, 2. 0, negative 2 is about right there. And this equation is negative 2x minus 2, so that one is negative slope, so it's going in that direction. So what does that mean? That the parabola is going to be somewhere. So, no, I'm just showing you what it looks like. This line is barely touching the parabola. Do you need to graph? No, I'm just showing you what it looks like. As long as you got this down, that's fine. However, look up, please. Is this the only type of solution that we're going to get from a system of a quadratic and linear? No. Look up, please. What do you guys notice there? How many solutions? Very good. 2. 1, 2. Where the graphs intersect. Here it goes again. How many solutions here? 2. How many solutions in the problem that we just did? Only 1, because it's barely touching that point. However, how about this one? How many solutions there? No solutions because they don't intersect. Those are the only possibilities. 0 solutions, 1 solution, or 2 solutions. Got it? All right. Number 18. Oh, yeah. Let me zoom in. It says, solve the system by elimination. Look up, please. These you need to use two of the equations and then use one of the equations with the third equation. So look up. I'm going to use first these two. So in blue, I want you to write them over here. Negative r plus 6s minus 4t. I'm going to put a capital T because some of you write with your feet. Equal to 17. And the second equation is negative 4r minus s minus 4t equals 7. So, to get started with these, we need to eliminate one of the variables. Look at these two equations. Which one is very close to being eliminated? T and R. R, what does this have to be right here in order to eliminate? Positive 4. How about this one if we wanted to eliminate T? Positive 4. So which one do you want to eliminate, the R or the T? T, all right. So I'm going to multiply the top equation. This needs to be a positive T, so I need to multiply times negative 1. So distribute, 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 distribute. That leaves us with positive R, negative 6s, positive 4t equal to negative 17. 17. Let's eliminate. We eliminate the t. Bless you. Combine these. We're left with negative 3r, negative 7s equals to negative 10. Did we eliminate one variable? Yes. Now we need to use the last equation over here, but we need to combine it again with one of these two. So I'm going to use the middle one. So I'm going to use this one and this one now. Write those down here. Negative 4r minus s minus 4t equals 7. Negative r plus s plus 5t equals negative 15. All right? But now we have to eliminate the same variable, which was t. You're like, oh, snap, Mr. Q. Yep. Look up. Are these close to being eliminated? No. However, if we treat the 4 and the 5 like if they were denominators, what would be a common denominator for these two? 20. That means we need to multiply this one times what? 5, and this one times 4. So here we go. Distribute. We end up with negative 20r, negative 5s, negative 20t equals 35. This one, negative 4r plus 4s plus 20t equals negative 60. All right, let's use elimination. These cancel, and we're left with, let's see, what do we have here? We have negative 24r minus s equals negative 25. Are we there so far? All right, so what do you notice now? We have two smaller equations, which is this one. Yes. Yeah, so some of you are saying, Mr. Q, why didn't we start with eliminating the r's? It would be a lot easier. Or the s's, because you guys told me you wanted to eliminate the t. I'm just showing you that it doesn't matter which one you start with, you have to do the same thing for the second pair. Could I have eliminated the r's first? Yes. Could I have eliminated the s's first? Yes. I'm just showing you that it's possible with any one that you start with. Okay? Don't get stuck. Here we go. So now we have this one and we have this one. So let's write them one on top of the other. We got negative 3r minus 7s equals negative 10, and negative 24r minus s equals negative 25. All right. We need to use elimination to eliminate. Which one is being close to being eliminated from there? Let's see. Let me ask Aldo. Which one is close to being eliminated? The s. But what does this need to be in order to eliminate the s, guys? Positive 7. So that means we need to multiply this times what? Negative 7. So distribute, that's 168r. Is that correct? Negative 7 times that, that's positive 7s equals 2. Negative 7 times that is positive 175, yes? Is that correct? All right. Elimination method, this cancels this. 168 minus 3, that's 165r. So we're using this one and this one, right? And what is negative 10 plus 175? 165. Divide by 165, divide by 165. R equals 1. Yeah, I know. So we got R. What do we need to solve for now from here? S. Which one do you want me to use, the first one or the second one? First, so I write negative 3r minus 7s equals negative 10. But instead of r, I substitute 1. Negative 3 minus 7s equals negative 10. This is negative 3 minus 7s equals negative 10. Plus 3, negative 7s equals negative 7. Divide by negative 7. So s equals 1. All right, are we done? No, let's see, which variable did we start with? Let's see, we have variables r, s, t. We already have r and s. Tell your neighbor what we need to do with those two variables to solve for t. Input into one of the three original ones. Doesn't matter which. You pick, substitute, and find me t. Ryan, which one are you using? Which one? The bottom one? Negative r plus s plus 5t equals negative 15. And instead of s, what goes there, everyone? 1. Instead of r, what goes there? 1. So we end up with negative 1 plus 1 plus 5t equals negative 15. What is negative 1 plus 1? 0. We're left with 5t equals negative 15. Divide by 5. T equals negative 3. Are we done? No, we need to write it in a coordinate form. Tell your neighbor which one you're going to write first. Yeah, they need to be in alphabetical order. R, S, T. So we write 1, comma 1, comma negative 3. This is my solution. Yes? What's that, Demi? I can't hear you. I still can't hear you. No, go ahead, go ahead. To the bottom corner, okay. Right here? All right, let's do another one similar to that. Let's go to number 19. 19. There it is. Solve the system by elimination. All right, now check this out. Notice that this is different than the other two. Is that correct? So what I want you to do, I'm going to give you a head start. I want you to write these two and then eliminate one of the variables. And then from there, you're going to write these two and eliminate one of the variables. And wait for me so we can do the whole system together. Everybody with me? You're going to rewrite these two over here, eliminate one of the variables. Then write these over here, eliminate one of the variables, and see what you get. I'll give you a head start. Go. All right, here it goes. Let's see if you did this. I wrote negative 3b plus c equals 15, and negative 2a plus 3b plus 2c equals 11. And I said, use elimination. Didn't I say that? Yes, Mr. Q. All right, which variable are you going to eliminate? 3b and negative 3b. And we're left with negative 2a plus 3c equals 26. Hands if you got that. Okay? Next I said use this one and this one. So I'm going to write again negative 3b plus c equals 15. And negative 3a minus 4b plus c equals 30. So which did we eliminate over here? B, which means we need to eliminate B again. Tell you what I just said. Yeah, it needs to be the same variable. Now some of you are like, Mr. Q, couldn't we eliminate C over here and then it would be easier to eliminate C on the other one? Yeah. But since you guys said B, then we're going to B. Let's see what we get. All right, so we're eliminating B. That means if we treat these like common denominators, what's our common denominator? 12. So that means we need to multiply this one times 4 and this one times negative 3. So 4 times this, it's negative 12b. 4 times this, it's positive 4c. 4 times this is equal to 60. All right. Negative 3 times that is 9a. Negative 3 times that is positive 12b. Negative 3 times that is negative 3c. And negative 3 times 30, that's negative 90. All right, now we can eliminate. This cancels. We're left with 9a plus c equals negative 30. Yes? Yeah, if you would have done negative 4 and positive 3, you should get the same answer. All right. So do we have two smaller equations now? Yes, Mr. Q. All right, so let's write this one on top of this one. Here we go. Negative 2a plus 3c equals 26. And 9a plus c equals negative 30. All right, let's see which one you want to eliminate. See? All right. So that means this one's already 3. What do we do to this one? Times what? Negative 3. That becomes negative 27a, negative 3c, positive 90. So now I'm looking at this one and this one. Here we go. Cancels. Negative 2a and negative 27, that's negative 29a equals 90 plus 26, 116. What's our last step? Divide by negative 29, divide by negative 29. A equals negative 4. Am I done? No, I need to solve for C. Which one do you want me to use, the top one or the bottom one? Top, so I'm going to write negative 2a plus 3c equals 26, but instead of a, I'm going to substitute negative 4. So we get negative 2 times that plus 3c equals 26. This is 8 plus 3c equals 26, minus 8 minus 8. 3c equals 18. Divide by 3. C equals 6. Am I done? No, I need to solve for B. Now check this out. Look up. Let me show you something really quick. We use the smaller one. Is that correct? Does the smaller one have B? Yes. Substitute the value for C in there and solve for B. Can you zoom out? Or I'll leave it right there for right now. Yes. Oh, wait. If you eliminate a different variable, no, you should get a different. You should get the same answer for the variables, but not the same, maybe not the same equation. It might look a little different. By where you distributed the negative, you should probably distribute the negative. Was it? All right, let's see. Let me zoom out. I'm going to use the top one. So I'm going to write negative 3b plus c equals 15. But instead of c, I'm going to write 6. We get negative 3b plus 6 equals 15. Minus 6 minus 6. Negative 3b equals 9. Divide by negative 3. b equals negative 3. My solution, negative 4, negative 3, 6. Solution. And we got that for B? Yeah? Okay. Number, doesn't matter in the order, no. We're going to do that in 2 minutes. All right. Let's go to number 20. Alright. Number 20. Here we go. It says, identify the transformation of the graph f of x equals x cubed. So they give us f of x equals x cubed already. You're like, oh, thank you. Because we don't have to graph that one. It's already graphed for us. But it says, that produce a graph that's given function g of x. The graph g of x on the same coordinate plane as the graph f of x by applying the transformations for reference points -1, -1, 0, 0, and 1, 1. So they're asking us, look up please, to take these 3 points in order to move the function to whatever transformation. Alright? So here we go. First of all, x, f of x. What do they give us? -1, 0, and 1. -1, 0, and 1. What is the y value? -1. What is the y value? 0. What is the y value? 1. So to make the transformation, what do we need, guys, for g of x? For this piece, we need to add one more column. Remember these? All right. So now they're asking us to do half of x cubed. 1/2 of x cubed. So, what's my x value here? -1. What is -1 times 1/2? Okay, let me repeat that again. What is -1 times 1/2? -1/2, but all that to the third power. So let's see, if it's to the third power, what is negative times a negative times a negative? Negative. So the answer is going to be negative. What is 1 times 1 times 1? 1. What is 2 times 2 times 2? 8. What is 0 times 1/2? 0 cubed is 0. Next, what is 1 times 1/2? 1/2 cubed. So, what is 1 cubed? 1. What is 2 cubed? 8. Alright, let's graph this. -1 with -1/8. -1 of x. Let me zoom in so you guys can see it. -1 and -1/8 is about right third. 0, 0, still there. And then 1 and +1/8, about right third. So that means it does this. So what do you guys notice? It's a stretch, but horizontally. Tell me what fingers how comfortable you are with these. 5, yes? Alright? So remember, just whatever they're asking you to do, just add the extra column for to do whatever to x. Okay? Go to number 21. Oh, yeah. Your favorite. But check this out. They're doing us here a favor in regards to, look up please. Notice on here, they're actually giving you the function. What to use. When I presented this to you guys, I did not give you this, and I had you memorize that. What did I ask you to memorize? G of x equals a parentheses 1 over b x minus h plus k. Remember that? Yeah, you have that in your noodle already, but to help you guys out, we left it with what you need to use, which is that. So look at it. By looking at it, look up. Let's label first our vertex. Out of these 3 points, tell your neighbor which is the vertex. That is correct. So with green, label that, and you're going to label this H, K. You guys remember these? All right. So to find, what are we finding? Guys? B. That means I'm going to use the point to the right of the vertex, which is this one. It says, graph the polynomial function, your favorite. Here we go. Ready? All right. First things first. We're going to set it equal to 0. 0 equals negative x squared times x minus 4. From there, in order to solve it, we need to factor, don't we? You're like, it's already factored, Mr. Q. Yeah, but this one is not. So I'm going to write 0 equals negative x times x minus 4. All right? So now, let's set each factor equal to 0. By the way, what is the visible coefficient here? 1. So I'm going to write 0 equal to negative 1, x equal to 0, x equal to 0, and x minus 4 equal to 0. Now, I'm being very obvious with these so that you guys can see what kind of function it is. So look up, please. How many x's do you see here already? 1, 2, 3. That means this one, the parent function is f of x equals x cubed. What does that mean, Mr. Q? Well, if it has an odd exponent, it usually starts here and it ends over here. However, look up to the screen. What do you notice here on this one? A negative, which means what? It's inverted. So now it's going to start where? Over here, and it ends over here. So no longer use these. I'm tic-tac-toeing this so you guys can remember. Okay, so now that we have the beginning and the end, now we just need to solve for these. Let's see. This one solved, this one solved. This one is not true, so we eliminate it. This one we add 4, x equals 4. All right, so let's start with this one. X equals 0. Here it is. X equals 0. Again, but I'm going to make a bigger dot or a bigger point. There it is. X equals 4. X equals 4 is right there. Okay. So, Mr. Q, what does this mean? This means that when we graph our function, it barely touches that point. It does not go through. Tell your neighbor what I just said. All right, here we go. Barely touch and goes through there. It barely touched and it goes through there. Yes? Go to your scratch paper. We're going to do another one of these to make sure we got it. I want you to graph me f of x equals x squared times x, give me a number, plus 2. Let's see, get us started, J. What do we do now? Very good. He said change f of x to 0 equals to x times x plus 2. Why? Because when we're solving equations, we want to see what the x's are. So then next step, we set each x equal to 0, or each factor. X equal to 0, x equal to 0, x plus 2 equal to 0. All right? So let's solve. This one's already solved. This one's already solved. And this one is minus 2 minus 2. X equals negative 2. So how many x's do you see? 3. So that means the parent function is x cubed. That means it's going to look something like this. It starts down here and it ends over here. All right, let's graph this. Unite. Zero, 0, negative 2. All right, here we go. If it's a positive in a cubic, it starts up here and it ends down here, yes? All right, here we go. Does it go through the 2? Yes. Does it go through this one? No, it barely touches, and it ends down here. Oh, my bad. We went the opposite direction. I'm sorry. I was saying to see if you're paying attention. My bad, my bad. All right, sorry. Here we go. Start here and here. Go through the 2, barely touch, and go through there. All right, one more. Last one, here we go. F of x equals, let's do x squared times x minus 1. If it's a positive odd number, so let's say it's x to the first, or x to the third, or x to the fifth, all those start down here and end up here. If it's x squared, x to the fourth, x to the sixth, x squared, it starts over here and it ends over here because it's a parabola, yes? X to the fourth, that means it does something weird here and it ends up over there. Same thing with this one. X to the sixth does something here and it ends over here. All right, let's see. You should have graphed 0, 0, positive 1, and it looks like this. Hands if you got that. Okay, good. All right, here it goes again. Explanation. Look up. When I gave you the anatomy of functions, it's the video right there on YouTube, a lesson that I did a whole explanation of the functions. I said, when you have a linear function, this is x to the first power. It starts in what quadrant? Quadrant 3, 2, 1, 4. Which quadrant did it start? In 1, and which one does it end? I mean, it starts in 3 and it ends in 1. Look at this one. What if and this is x to the first. X to the third looks like this. Where does it start? 3 and it ends in 1. If I gave you x to the fifth, that means possibly how many times is it going to touch or go through the x-axis? 5 times, not only 3 now. But it still starts down here, like that. It always starts where? On the third quadrant, and it ends in the first. So what does that mean with the squares, Mr. Q? If I have x squared, it's a parabola. What quadrant does it start? It starts in quadrant 2, and it ends in quadrant 1. Yes? So that means if I have x to the fourth, it's going to look like this, kind of funky somewhere here, but it also starts at 2 and it ends in 1. How about x to the 6th? Starts over here, does something weird here, and it ends there. Remember the decimals activities that we did? It kept stretching at the bottom? Okay, good. All right, number 23, Michael Jordan. Here we go. It says, find the polynomials that model the problem. A rectangle. So what is the first thing you're going to draw? Yeah, draw a rectangle. As nice as mine. There it is. All right, let's label this. A rectangle has a length of x. So that means, what do you want to label the length? This one? X and x. And the width of this? 5x cubed plus 4 minus x squared. 5x cubed minus, plus 4 minus x squared. They say find the perimeter. Everyone, how do we find the perimeter of any figure? Add all sides. How many sides do we have here? 4. Perimeter is equal to side plus side plus side plus side. Perimeter equal to x plus 5x cubed plus 4 minus x squared plus 5x cubed plus 4 minus x squared. All right, combine like terms, please. Let's see what you get, and set it in standard form. All right, Sky, over there. I'm sorry? The what? Oh, thank you. Yeah. All right, perimeter equals, who got 10x cubed minus 2x squared plus 2x plus 8. Hands if you got that. Yeah. All right. But now check this out. But they say that the length is 5 feet. What was the length? X. So that means that x is what? 5 feet. So what do we need to do here to this part? Substitute 5. Substitute 5. Substitute 5. P equals 10 times 5 cubed minus 2 times 5 squared plus 2 times 5 plus 8. Okay, I'm going to go a little faster. Here we go. Perimeter equals, what is 5 times 5 times 5? 125 times 10, 1250. All right. Minus 25 times 2, that's 50. Plus 10 plus 8. Combine stuff. Perimeter equals 1218 feet. There it is. And let's write our statement. A rectangle, rectangle, find the perimeter. So then the perimeter of the rectangle is 1,218 feet when length is 5 feet. 10 cubed. So clear, the perimeter of the rectangle is 1218 feet when length is 5 feet. Show me the famous how familiar you are with these? Yeah, just substitute and yada yada. Number 24. Here we go. Find, yes. Find the square of the number in the product using one or more of the identities. So this is going to be easy because you have the identities there. You don't need to memorize them, I guess, because we're giving you those. Here we go. Let's rewrite 23 squared. Remember how to write these as a binomial? Yes. How do we write it? 20 plus 3 squared. Which identity shall I use? The first one, this one. Is that correct? So that means the pattern that I'm going to use is this: x squared plus 2xy plus y squared. But instead of x, what do I have? 20. And instead of y, what do I have? 3. Therefore, I'm going to write 20 squared plus 2 times 20 times 3 plus 3 squared. And you simplify. 400 plus 120 plus 9. Therefore, 529. That's just the answer like that. Nothing, no? Do another one? Huh? May you use your calculator? Yeah, at home, not in the final. Woo! Let's go. Let's go. Yeah, you guys are my calculators. You want to do another one of these? No? Go to number 25. Here we go. Focus, please. Two numbers given. 34 times 42. Here we go. I need to rewrite these as binomials, but they need to have one common number. So look what I'm going to do. Write your pencils down. In class, I gave you two numbers that were close to 30, both of them. These are not close to 30, both of them. So what I'm going to do, I'm going to say, how many steps is from 34 to 42? 8. That is correct. So what is the midpoint between both numbers that both of them will have in common? What is the midpoint? So how many steps will be halfway? 4 and 4. That means that there's a number halfway between the two that's 4 steps away from both of them. What is that number? 38. Now that I have my magic number, I'm going to write 34 using 38. So how do I write it? 38 what? Minus 4 times. How do I write this one? 38 plus 4. Yes. There's two distances. What's halfway for each? Half of 8. The full distance from here to here is 8. Yes? All right? So, which identity do we use for that one, everyone? It looks like this one, yes? So that means instead of x, I'm going to write 38, and instead of y, I'm going to write what? 4, but I'm going to use this format. So I'm going to write 38 squared minus 4 squared. All right? So 38 squared. What is 38 squared? 38 times 38, 8 times 8 is 64. We got 6. 24 plus 6, that's 30. 24, got 2, 3 times 11, that's 14, 4, 4. So that's 1, 4, 4, 4 minus 16. So what's 14, 44 minus? Yeah. No, the negative is just negative. Yeah. So what is 144 minus 16? 1428. That's it. Let's do another one of these, and this is going to be the last one. For numbers 26 through 31, we're going to do those during tutoring after school on Monday, and I'll post a video for that. Okay? All right, here we go. One more of these. Let's do 40, give me a number. 1 times 50. Multiply those two, but write it first as a binomial and find me the identity, and use the pattern for the identity. I'll give you some time for that. Oh, we're going to end up with a decimal? Yeah? All right, fine. Let's change this to a 2. All right, let's see. Joaquin, what's the middle number? What was it? 46. Hands, have you got 46 for the middle number? Yes. How did we get that? Let's find out. How many steps from 42 to 50? 8. Midpoint, that means there has to be 4 steps from that number, 4 steps from that, so that gives us what? 46. So let's rewrite this. This is 46 minus 4, and this one is 46 plus 4. Yes? Yes, Mr. Q. So we write 46 squared minus 4 squared. All right, who's got 46 squared? Jalen, what'd you get? 46 squared. What is it? 4160? 2116 minus 16. So this is 2100. And have you got that? Yeah, looks about right. We're going to stop right there, guys. So once again, Monday we start our final. We finished up to problem number 25 today. Like I said, I'm going to upload the video on Monday for the last 5. So home play for the weekend, make it a family math night. Family last night. Tell them, gather around. Let me show you what I did. And study, please. Good one. See you guys till Monday. Bye. Don't forget to throw away your socks, please. Please, pretty please, with a cherry on top.